In this work, we present an efficient yet natural-looking gaze animation model applicable to real-time walking characters exploring natural environments. We propose a new method for motion-aware saliency estimation based on findings of studies in motion perception and an attention decision system built from drift diffusion models, a concept often applied in neuroscience and cognitive studies, to determine whether the walking agent should focus on an external object or on its path, based on current environmental conditions and its internal memory. In the following videos, we highlight the agent's current fixation point through the white circle shown on the screen. We conducted a perceptual evaluation to compare our approach with the current state-of-the-art in saliency-driven gaze animation, which is directed towards static agents and does not take into account the motion saliency of external stimuli. As baseline, we used a simple animation where the character only looks forward. We evaluated the character's apparent awareness of the environment, the naturalness of the head and eye motion, and the elements at which it pays attention, referred to here as gaze target. Our results show that our solution significantly improves upon the state-of-the-art in all evaluated aspects. The videos shown here are the exact videos shown to the users during the perceptual evaluation. Our model can also display two different gaze behaviors according to the desired degree of visual exploration of the environment, which we refer to as goal-driven and exploratory. Goal-driven means that the character will tend to look more towards its path and will spend less time looking at external stimuli. Meanwhile, an exploratory character will prioritize looking at interesting objects and spend longer amounts of time looking at them. We conducted an additional perceptual evaluation, asking users to label the displayed videos as either goal-driven or exploratory. Our results show that the users were able to significantly tell the difference between the two behaviors, correctly identifying them in each video. Here, we present an ablation study applied to one of our test scenes. In the first example, our character is unable to perceive motion, which makes it so that it completely ignores the birds and butterflies along its path, while focusing on salient points on the terrain and vegetation. The opposite happens in the case where we do not consider image-based saliency. The character is very attracted to motion and ignores the salient vegetation. Finally, having the character not look and anticipate its path while walking can also seem unnatural, as we often remain attentive to where we are going in locomotion tasks, even in explorative contexts. Finally, we show an example of an interactive real-time demo where a user controls the character while our model outputs the gaze animation. As we can see, the character's gaze and head are able to react to the stimuli as they come within its field of vision, and it can also try to anticipate the path given the current direction of the user's input. This shows that our reactive gaze animation can make the character seem much more responsive and alive, and is applicable to real-time scenarios such as games and VR applications.